Okay, let's look at imaginary and complex numbers. So, yeah, I said it. Imaginary numbers. This is a major concept in Algebra 2. Things are about to get imaginary in mathematics. I know. You're cringing. It's okay. Maybe you've seen them before. These cute little eyes, like the letter I, they stand for imaginary. So now we're finally going to dive in. We're going to teach you about it. I do have a little warm up here to help us. Um, get started, we do need to review radicals. So there was a point and there was a purpose our first few days of school listing our perfect squares. You've got 1 times 1 is 1, 2 times 2 is 4, 9, 16, 25, 36, 7 times 7, 49, 64, 81, 100, 121, 144, 1, let's see, 13 times 13, 169, 196, and 225. Woo! Just reviewing. They're good to know. Obviously, probably 1 through 36 are the only ones we're really going to need or use when it comes to simplifying our radicals. So let's review that. How do you simplify radicals? Because guess what? You're about to have to do it. On this first one, square root of 75 x squared y. There are multiple things here in our radical. I'm going to separate those. The square root of 75 you can break up into 25 times 3. I'm going to show this as well. The square root of 25 is 5. The square root of x squared is a single x, and we're going to have to leave 3y in the radical. On the second one, square root of 16, x to the fourth, and y to the third, all in the radical. I'm separating those up. The square root of 16 is 4. The square root of x to the fourth is x squared. That y cubed, though, it's an odd number. 3 is odd, so you're going to have to separate that into y squared and y. And you can take the square root of y squared is y, and we'll have to leave a single y inside the radical. The third one, you've got 28 in the radical. You've got an x cubed in the radical and a y cubed in the radical. You would break up 28 into 4 times 7. You don't want to choose 2 and 14 because neither of those are perfect squares. So like 4 times 7, since x to the cubed, or x cubed is odd, I'm going to break that up into a squared and 1 left over, and same with the y, a y squared and 1 left over. All right, square root of 4 is 2. Can't do anything with square root of 7. I'll leave that in the radical. Square root of x squared is x. Can't do anything with a single x in a radical. Square root of y squared is y. And in the radical, let's see, we've got a 7 left over, an x, and a y. All right, you feel warmed up? There's one last example here, the square root of negative 4. Square root of negative 4. Usually students will tell me negative 2, and I'm like, that's cool. That's cool, but let's remember what a square root represents. So you're telling me negative 2 times negative 2 is negative 4? No. No. Negative 2 times negative 2 is positive 4. When you multiply two negatives, it's positive. So that's not it. What are we going to do? All right, I'll show you. Let me erase this. We are going to use our radicals, are simplifying our radical properties, and I'm going to rewrite it. What's the problem here? The problem is that negative, that pesky old negative. So I'm going to rewrite it as the square root of a negative 1 times the square root of positive 4, because I can find the square root of 4. I know the square root of 4 is 2. So I'll have 2 and the square root of negative 1. Things seem okay, yes? They seem okay. We're okay. Well, that's where imaginaries came from. Let me highlight this. That square root of negative 1, That's an imaginary. And we're going to look here on our notes. The square root of -1 is equal to I. It's right there. So let's read that definition. An imaginary number is any number of the form bi, where b is a real number and I is equal to the square root of -1. So where I wrote the square root of -1 over here, we would replace that with I. A cute little cursive lowercase I would replace that. Some examples here, 2i, 2 is that b, the real piece, I is the imaginary. It can be a negative number, -5, then I. We can have division, we can have I radical 5, we can have all kinds of things. But b is the real piece, and then we put the I at the end if we have an imaginary unit. The imaginary unit I is the complex number whose square is -1. So if we said I is equal to the square root of -1, that would mean I squared is equal to -1. I know I'm blowing your mind. So let me give you an example that you do know. So 2 is equal to the square root of 4, right? If I take 2 and I square it, that is just 4. Okay, so do you see how that works? If I is equal to the square root of -1, when I square it, it's just equal to -1. That's what that sentence is saying at the top. So I'm going to erase this because you have it right there in the box that I is equal to the square root of -1, and then I squared is equal to -1. Okay, remember that because we're going to be using it a lot. And I'm going to make you a quick table for a purpose here, looking at I to the first power, I to the second power, I to the third, and I to the fourth. I to the first power is just I. I to the second power. If you did I times I, you have it up here in the box. I times I is -1. If you multiplied those two together, let's say we're looking at I cubed, but that would be equivalent to I to the first times I to the second, which we already said was I times -1. That gives you -I. And then I to the fourth, that would be the same as I squared times I squared, which we labeled as -1 times -1 makes +1, okay? So you think I'm crazy right now? Let me give you a helpful tool to memorize these because you need to kind of know these first 4 to answer the questions below. So you need to memorize these 4. And the way I do it is I won. Like I won. With negatives in the middle. Writing it on my notes here. Okay, so see, you've got an I, and then a 1, and then an I, and then a 1, and the 2 in the middle get negatives. And that's going to be your memorization tool. When I do problems with you, I'm going to write it off to the side, I1, and put negatives in the middle for I to the first, I to the second, I to the third, I to the fourth. If you can memorize those, you can do these problems below. So we are going to use that to answer these questions. Number 1, I to the 49th. Miss Bryan, you listed 1, 2, 3, 4. How am I supposed to get to 49? Well, here's the deal. This pattern continues. It loops. Guess what I to the 5th is? I. It just loops back around. Guess what I to the 6th is? -1. Guess what I to the 7th is? -I. It's just going to keep looping around this pattern. Those are the only 4 you need to memorize, and it keeps looping that same pattern. Notice our favorite. Notice our favorite here is going to be I to the 4th is equal to 1. We love 1 in math class. So we are going to take, for number 1, I to the 49th, we are going to take 49 And I'm going to divide it by 4 because I want to see how many times the I power is going to go through this loop of 4 answers total. So grabbing my calculator, I'm going to do 49 divided by 4. Gave me 12.25, which is also 12 and 1/4. So it went through this pattern of 4 answers 12 times, and then it landed on one of the 4, the first of the 4 answer choices. So I to the 49th is equal to the same thing as I to the first, plain old I. Just I. Let's do it again. This is a standard. These are the types of questions that you would see on a non-calculator portion of EOC or a benchmark. Okay, keep that in mind. Number 2, I to the 91st. I to the 91st. So we're going to take the 91 and I'm going to divide it by 4 to see how many times it is going to loop through these answers, because it does repeat those 4 answers over and over and over. 91 divided by 4 gives me 22.75. which is 22 3/4 of the way. I'm going to erase this arrow. So we did 22 times through those answer choices, and we landed on 1, 2, 3. Way 3, the third answer of the 4, which is negative I. I to the 91st is equal to negative I. Do it again. Number 3, I to the 52nd. I'm going to go take 52 and divide it by 4. And it gives me 13. 13. It goes through this pattern 13 times. So where does it land? It went through the pattern 13 times. It's going to land here at I to the on the 4th answer, which is positive 1. I to the 52nd is equal to positive 1. So what some students like to do on their table over here, let's add it. They like to put that I to the first is when you get a 25 hundredths decimal. I to the second is when you get a 50 hundredths. I to the third if you get 75 hundredths. And then if you get a whole number, it's going to be equal to I to the 4th, okay? And remember that pattern is I won with negatives in the middle, okay? Let's try number 4. I to the 34th, I'm going to take 34 and divide it by 4 is 8.5. So it goes through the loop 8 times and it landed at 0.5. Has the same answer as I squared, which is I won, negatives in the middle, negative 1. I to the 34th is equal to negative 1. Number 5, I to the 24th times I to the 25th. Let's use our exponent rules. We're going to combine this into 1, and then we'll evaluate it. So remember, exponent rules, we are going to add those together and get I to the 49th. I'm going to take 49 and divide it by 4, and I get 12.25, which means it is landing in the first box, or it is equal to just a single I. Number 6 is the same. We all multiplying together, so let's add up all those exponents. 5 plus 33 plus 26 is 64. So we have I to the 64th. I'm going to take 64 and divide it by 4. And it gave me 16, the whole number. Gave me a whole number. So it is equal to the last box, positive 1. All that mess, number 6, I to the 5th times I to the 33rd times I to the 26th is equal to 1. Okay, so you do have these questions that come up on benchmarks, EOC, and that's all you have to do. You got to remember I won with negatives in the middle, and you're going to take your exponent, divide it by 4 to see how many times it looped through, And then the decimal place is going to tell you which answer, I1, I1. Negatives in the middle. Here's some extra little notes. When there is a negative inside your radical, your answer is going to have an I in it. So look at our examples below. Look at all those negatives inside the radical. All of those are going to have an I in my answer. When I finish, I better have an I, because remember our definition is I is equal to the square root of -1. So whenever I see a negative, there's going to be an I in my answer. Second bullet point, write I and then your radical, for example, 17, instead of square root of 17i, because somebody might think it's the square root of 17i. Okay, so put those things in front, your radical at the end with anything that's inside the radical. We don't want anybody to be confused. Ready? Number 7, the square root of 121. I got your back. We're starting slow. We're starting easy. Here we go. So the problem is, just like our example at the top, the problem is that pesky negative. So let me rewrite it as a positive 121 times a -1. Okay, because I know the square root of 121. What's the square root of 121? 11. What's the square root of -1? This is our new thing. Square root of -1 is equal to an I. So this answer here is 11i. The square root of -121 is 11i. Number 8, the square root of -17. I'm going to separate it as a -1 because the problem is that's pesky negative, -1, and a positive 17. The square root of -1 is I. Square root of 17? It's not a perfect square. In fact, it's prime. You can't even break it down into anything smaller, so we're going to leave it as I radical 17. Number 9, the square root of -75. Pesky negative. Let me remove that negative or show it as a square root of a -1. And then 75. If it's positive 75, let me show all my steps here. We can break that down into 25 times 3 because I can take the square root of 25, all right? We've got an I, we've got square root of 25 is 5, and then we have -3. Now watch how I order this. I want to do my whole number, I want to do then my imaginary unit, then my radical, okay? At the very beginning, we talked about writing our imaginary units as the real piece and then the imaginary. We called it BI up there in the notes. Then you want to put your radical. So 5i radical 3 is the correct way to order all that information. Number 10, the square root of -24. Pesky negative. My final answer will have an I in it. I'm going to separate this as a -1 with positive 24. Now, can I break down 24? Let's do 4 and 6. Now, I'm going to put over here, we're going to choose 4 and 6. There's also 3 and 8, but neither of those are perfect squares. So you want to choose 4 and 6 to help you simplify. Okay, the square root of -1 is my I. The square root of 4 is a 2, and there's nothing more I can do with 6. So order it correctly, 2i radical 6. Final answer. Number 11, pesky negative. I've got a -1, positive 128. You can take your calculator. If I did 128 divided by 4, it gave me 32. 32 is still pretty big. I think I can go bigger and get a faster simplification. So 128 divided by 9. No. 128 divided by 16. 8. Can we do better? Do you already know it? 128 divided by 16. Oh, that's the one we just did. 128 divided by 25. Nope. 128 divided by 36. Nope. 128 divided by 49. Nope. 128 divided by 64. 2. Okay, so we mentioned several, but we want to go to the biggest and the fastest and the quickest. -1, 64, and 2. If you chose any of the other ones that we mentioned, like, oh, that would work. What was it? 128 divided by 4. We mentioned 4 times 32. You can use that, but then you have to break down 32 again. 128 divided by 16 was the 8. But you can break down 8 again because it has a 4. 4 likes to hide. So we are going with 64 and 2 because 64 is a huge perfect square. All right. Square root of -1 is an I. Square root of 64 is an 8. And we'll have to leave the 2 in the radical. Write it in the correct order. 8 I radical 2 is our final answer. Number 12. There's a -3 on the outside. It's okay. Just leave it there. Let's talk about the negative inside my radical. That's an issue. That's a problem. Let's separate it. Okay. Now, what did I just say? 4s like to hide. There is definitely a 4 in that 20. Let's break it up into 4 times 5. All right, -3 is chilling. Square root of a -1 is an I. Square root of 4 is a 2, and we'll have a 5 still in the radical. Put it in the correct order. Now we've got -3 and 2. We've got two numbers. Multiply them together. Multiply them together. -6I radical 5 is final answer there. 13. Fully simplify 6 radical -7 times the radical -3. All right, on these, you want to simplify before you multiply. You hear me? I'm preaching it. Simplify before you multiply. Okay, so let's see what we can clean up in the first parentheses. The first factor, obviously there's nothing I can do about a 6, but let's change this to a -1 and a 7. And same on the second one, change it to a -1 and a 3. Okay, so we'll have a 6. This becomes my I and a radical 7. Square root of a -1 is another I and a radical 3. Now, when you multiply radicals, things on the outside get multiplied together. So we have 6I and the I get multiplied together. 6I times I is 6I squared, right? If you had 6x times x, would it not be 6x squared? Okay, same thing works here. So then multiply your radicals together. Anything inside the radicals can be multiplied together. 7 times 3 is 21. One more thing you need to do. At the top of our notes, what did we say I squared was equal to? -1. So this becomes 6 times a -1, or we have -6 radical 21. All right, so let's look at number 14. Remember to simplify and then multiply. Okay, so the first one, we've got 7. That square root of a -1 is your I, so you can already simplify that. Then we have 3. I'm going to break up that negative out of the radical with a +4. So I have 7I times 3. There's your I. 3I. Ooh, and that's a 2. So I'm going to have that times 2. Show all my steps here. 7I. 3 times 2, 6I. Now multiply. 7 times 6 is going to give me 42. And I times I is I squared. Whenever you see I squared, I need your eyes to go whoop. I squared is equal to -1. So this becomes, I'm going to show all my steps for you. -1 giving us -42. 2 more on the second page. Let's see. Number 15, simplify, then multiply. So I don't see anything in the first one I can do. But I can change this second piece with my imaginary. We'll have 9. Let me change it to -1 and a +7. That'll become an I. So we have 4 radical 2 times 9i radical 7. Multiply the things on the outside. The 4 and the 9i will give me 36i. Inside the radical, I have a 14. And then you would check to see, can I simplify the radical? But 14 is not going to break down with a perfect square. Number 16, square root of 64, that's 8. I got 9 times 8 right there, which is 72. We've got a -1, and then let me fix our radical, breaking it up into the -1 and the +5. The -1 is going to be an I, so we've got a -1i square root of 5. Now multiply things on the outside of the radical. The 72 and the -i gives us -72i, and we only have radical 5 left. There you go. So that should be about all the different types you kind of see on Delta Math. So review those, practice those. Complex numbers, this is just building. This isn't anything new. Just a complex number is when we have 2 terms and there's imaginaries involved. So a complex number is a number in the form of a plus bi, 2 terms, where a and b are real numbers and still I is equal to the square root of -1. For example, 2 plus 3i would be a complex number. It's got a real piece and it's got an imaginary piece, so it makes it super complex. 2 is the real piece and imaginary part is the 3i. Write your final answer in that form. Always put your real, then plus or minus your imaginary. Let's start with adding and subtracting. You just combine like terms. Make sure when you are subtracting, distribute that minus sign through first, so you're not going to accidentally combine and forget that you were subtracting. Let's dive in. Number 1, we've got 6i plus the quantity of 2 minus I. That parentheses, they're not doing anything. They're just grouping, so you can just take them off and you can start combining your like terms. So we want to combine all our real pieces first. The only real piece we have is a 2, and we write that first. Then combine all our imaginary pieces. We've got a 6i and a -i. That will add up, just like terms, will add up to 5i. 2 plus 5i. Number 2, you've got -7 plus 2i plus 5 minus 11i. Again, the grouping symbols aren't doing anything magical other than grouping, so we can drop them off, ignore them, and start to combine our real pieces. We've got a -7 and a +5, gives me -2. Combine your imaginary pieces. You got 2i minus 11i gives you -9i. 13, we're subtracting. We are subtracting. Hello, heads up. So you want to make sure you don't overlook the subtracting as it goes across the second term, that 3i. So I always recommend, I always do it, rewrite it. Then you can combine like terms without worry. Our real pieces, 18 minus 2 is 16. Imaginary 27 and a -3 is going to give me -24i. Do it again, number 4, it's another subtracting, so I'm going to distribute across. That's going to give me +2 minus 3i. Then combine, real, gives me 7. Imaginary, a -3 minus 3 is -6i. Another subtracting example, rewrite it. So you get +5 plus 9i. Real is 5. Imaginary, 4i plus 9i gives us 13i. Okay, so there's examples of adding and subtracting. Complex numbers. Pretend the imaginary, the I, is like x, like a variable. What would you do? You treat it the same way. To multiply, same as we've done with variables before. I use the FOIL method, first, outer, inner, last. It does the same thing as distributing. So use those skills to multiply. The first one, let's see, we've got 3 things being multiplied together. So let's start left and move to the right because I will have to distribute across that. So the first 2, when I multiply together, 4i and negative 5i gives me negative 20. Watch out, I squared. I squared. I squared is equal to a negative 1. So we really have positive 20, and we're going to multiply across 3 minus I. 20 times 3 is 60, and 20 times negative I gives me negative 20i. Number 7, you've got 2 binomials, so you have to FOIL, first, outer, inner, last. I'm going to multiply my first terms together. 6 times 4 is 24. I'm going to multiply my outside terms. 4 times negative 2i is negative 8i. Inner, 9i times 6 is going to give me 54i. And last is going to give me negative 18. Watch out. I times I is I squared. I squared. I times I is I squared. So watch out for those. Anytime you're multiplying your i's together, make sure you add up your exponents there. All right, combine your like terms. We've got like terms in the middle here. Negative 8i plus 54 is 46i. Now this I squared became a negative 1. So now I have plus 18. At the end, I need to combine my 24 and my 18 to give me 42. Now we write real 42, then imaginary 46i. Final answer. Number 8, do it again. First makes negative 21. Outer makes negative 12i. Inner, 12 times 7 is going to be 84. 84i. Last is going to give me 48i squared. Negative 21. We've got negative 12 plus 84 gives me 72i plus, I squared is a negative 1. Let me go ahead and change that to negative 48. Combine my like terms. Negative 21 minus 48 is going to be negative 69 plus your imaginary. Real, then imaginary. Negative 69 plus 72i. Two more examples. First, 6 times 3 is 18. First, outer gives me negative 60i. Inner gives me negative 15i. And last is going to give me positive 50i squared. 18. Combine my like terms in the center. I'll have negative 75i. My I squared, that's a negative 1, so I'm going to write minus 50. 18 minus 50. Negative 32 minus 75i. Final answer. All right, last one, most important one. I hope you've watched the video and you've caught number 10 because this one is big deal, big deal. Number 10, see that squared? You better not take that squared and just drop it in and think you're good. That squared means that there were 2 parentheses of the same thing multiplied together, right? That's what squared means. Now do FOIL. Now multiply it. First, 3 times 3 is 9. Outer gives me negative 6i. Inner gives me another negative 6i. And last, positive 4i squared. Whoop. 9. Combine your like terms in the center. Negative 6i minus 6i, negative 12i. And then we had 4I squared. That I squared is a -1. So I'm going to write -4. And combine my real pieces. 9 minus 4 is 5 minus 12I. Final answer. Now, if Miss Bryan, why don't we just drop in that squared? Let me just show you. If you just pretend that that's going to be okay and you drop in your squared. Okay, 3 squared is 9. And then maybe you copy down the minus sign and you do 2I squared is 4I squared, and that's a negative. I have 9 plus 4 is equal to 13. Or maybe you do it a little bit different. Maybe you do 9, but you square all of that. You'll have plus 4I squared or something, and you still get 9 minus 4, which is 5. Neither of those answers look like our final answer. These are wrong. Bad, bad, bad. No, no, no. Little baby squared cannot be dropped into your parentheses. No way, ever. No. Write it twice and FOIL. How about I put that on our notes? Write it twice and FOIL. So that's imaginary and complex numbers, guys. Imaginaries are going to be all in our curriculum. That's what makes Algebra 2 Algebra 2, is because we talk about these imaginary units, so expect them. We talked about simplifying our radicals because we ended up using it with our imaginaries, and then we looked at I1 with negatives in the middle. They're going to repeat those 4 answers over and over and over. So if you have a large exponent with an imaginary, divide it by 4 and see what you get. Do you get 0.25, 0.5, 0.75, or did it come out as a whole number? We'll tell you what it's equal to. Simplifying those radicals with negatives, getting those imaginary units, because we're going to be solving in the future with radicals, and we're going to get imaginary units, and then we added, subtracted, and multiplied with those imaginaries. So remember, I is equal to the square root of -1, and also I squared is equal to -1. In the box on the first page, highlighted, if you can remember that, and I1, that's this lesson, okay? I'll see y'all in class. Have a wonderful day.